I'm Ryan Nickel, CTO at DSA, and today I want to show you how to do a basic current deflection analysis for a subsurface mooring using Proteus Oceanographic and ProteusDS. We've already configured a basic subsurface mooring in Proteus Oceanographic. You can see we have a top float. As it happens, there's two ADCPs attached to it. There's two connector assemblies and some wire rope. It's about 100 meters long and it's a 1,000 meter water depth. We've set a current profile here, and we have rough estimates of top tension and anchor tension, but this is just basic static weight and buoyancy. It doesn't give us any idea of what the deflection of the mooring is or what the drag loads do to the system. Here's where we work with ProteusDS now. So we'll click on Solve, and there's two things you can do here, export static and export dynamic. For most subsurface moorings, all you need to do is a static analysis, so we're just going to export static to ProteusDS Simulation Toolbox. What's going to happen is Proteus Oceanographic is going to generate all the input files for a ProteusDS analysis. So click on Solve. I'm going to navigate to my folder here where my files are. I'm going to make a new subfolder. You don't have to do this, but that's what I like to do to keep things organized. And I'm just going to call the ProteusDS project file just static. Okay, so we'll minimize this. Go to the static folder. Now you can see here are the ProteusDS input files. Double click on static to open it in ProteusDS Simulation Toolbox. And you can see we have a quasi-static cable ready to go. You can see our two ADCPs in here and the hardware that we configured in the system. So all you need to do is hit run. Previously, we had created some project templates to work with and for oceanographic moorings, and Proteus Oceanographic largely replaces the need for using project templates. And you can see it's solved for the mooring deflection now. We can see what that looks like using PostPDS. This is a visualization tool that'll show us what the deflection looks like. We just click OK past the loading options. Now, PostPDS is great. It gives you a nice realistic view of what the ocean looks like. You've got some clouds and you can see your hardware and stuff like that in the water. The problem is a lot of moorings are so big it's hard to see them. And so what I normally like to do is I change to Home tab and click, instead of rendered, I do engineering view. That changes the water surface to a grid, but we still don't know where our mooring is. So the other thing I like to do, you can find the mooring by double clicking on it here. But we still have this perspective projection. It's what it would look like if you were really there, and it looks like from your perspective what it would look like. So a better way of looking at what the mooring deflection looks like, if we go to settings and we click orthographic view here, we can get a nice side view of the entire mooring. So go back to home, and then if you select camera preset east, the current by default flows from the south to the north, and that's going to go and make the mooring deflect towards the right here. So we've got this east view with engineering view on. We can even show the nodes of the finite element mesh that have been generated automatically for us. Those aren't little floats, those white dots are the finite elements there. That just helps to kind of give a sense of how many elements are involved. And now we'll see what the mooring looks like deflected in the current profile that we set. So you can see there's the top of the water depth. Remember, we're in 1,000 meters water depth and only 100 meter long mooring, but we had quite a strong current and we've got some deflection there. Well, that's nice, but what does the actual numbers look like for excursion and knockdown? That's where the report tool comes in handy. So I like to do a visual check, but I don't do it on all my moorings analysis projects. So we'll go click on the report tool here. And what we want to pick from this is subsurface, because we did a subsurface analysis, quasi-static single leg mooring. Go OK. There's a number of options here. Everything is set up and ready to go for you as is, so you can just click on Generate Report. And what it's going to do is go through all your results and calculate everything for you. You can save it. It's just an HTML file. You can save it in the default location. Sometimes I like to save it in with my project files. Here I just go up one category and go Save. There, it's calculated all the values. Now we can view the output report from this. This is a ProteusDS report template. I'll make the text a tiny bit bigger. It's a summary of all the inputs and all the outputs. You can see that we've got water depth here, summary of the current profile that we put into the system, and a summary of the inputs. What I really want to look at is the steady current condition loads, and I'm going to go down to look at the knockdown of the Workhorse Long Ranger. That's going to be the spherical ADCP buoy. You can see knockdown is 4.4 meters, height above seabed as well. We also have the inclination, tilt, 11 degrees, and the horizontal excursion of almost 30 meters as well. So just some key numbers you get out of the analysis, and that's the summary of what I wanted to take you through in working with the subsurface mooring analysis with ProteusDS Oceanographic and ProteusDS. Thanks for watching.